Download this code from codegive.com, link in the description below. Blockchain unconfirmed script for free Bitcoin, an in-depth tutorial, updated with code example. Disclaimer *, this tutorial is for educational purposes only. I am not responsible for how you use the information provided here. Attempting to manipulate or cheat free Bitcoin, or any other faucet/service, is against their terms of service and may lead to account suspension or permanent ban. Consider this a research project and use the information responsibly. This tutorial will explore the theoretical concept of using blockchain unconfirmed transactions to potentially manipulate free Bitcoin, along with providing a code example. However, I strongly advise against using this information for malicious purposes. Understanding the core concepts. Before diving into the script, we need to grasp the underlying principles. Blockchain and transactions. The blockchain is a distributed, immutable ledger that records transactions. Each transaction consists of inputs, Bitcoin being spent, and outputs, Bitcoin being received. Unconfirmed transactions. When a transaction is broadcast to the Bitcoin network, it initially resides in the mempool, memory pool, of nodes. These are unconfirmed transactions, awaiting inclusion in a block by miners. The confirmation process relies on miners solving a complex cryptographic puzzle, adding the block to the blockchain, and validating the transactions within it. Transaction fees and confirmation time. Transactions with higher fees are generally prioritized by miners because they earn more from including them in a block. Lower fees might result in longer confirmation times or even eventual rejection. Free Bitcoin mechanics. Simplified, free Bitcoin is a Bitcoin faucet that rewards users with small amounts of Bitcoin, satoshis, at specific intervals. They employ various methods to prevent abuse, including IP address tracking, bot detection, and potentially tracking claimed amounts. They likely monitor suspicious activity that could impact their revenue. Double spending. Relevance. A double spending attack involves spending the same Bitcoin twice before a transaction is confirmed. This is the core vulnerability that miners protect against. 2. The theoretical exploitation concept. The hypothetical vulnerability this tutorial addresses leverages the window between broadcasting an unconfirmed transaction and its eventual confirmation. The idea is to 1. Create and broadcast a legitimate Bitcoin transaction, TX1, to fund your free Bitcoin account. This is a real deposit. 2. Initiate a high-value roll on free Bitcoin based on the deposited funds. You aim for a lucky roll with a large payout. 3. Create a second Bitcoin transaction, TX2, spending the same inputs as TX1, but sending the Bitcoin to an address you control. This is a double spend attempt. TX2 might offer a significantly higher transaction fee. 4. The hope is that TX2 is confirmed before TX1. If this happens, TX1 becomes invalid, and the original free Bitcoin deposit is effectively cancelled. You would then have the larger winnings from free Bitcoin and your original Bitcoin. Why this is extremely difficult, and usually fails. Rarity of success. Many factors need to align perfectly for this to work. Bitcoin miners generally prioritize confirming the first transaction they see, TX1, to prevent double spending. High transaction fees. TX2 needs to have a substantially higher fee than TX1 to entice miners to prioritize it. This can be very expensive and might negate any potential profit. Free Bitcoin detection. Free Bitcoin likely has countermeasures to detect and prevent this type of manipulation. They might delay payouts until confirmations are received, track suspicious patterns, or even blacklist accounts that attempt such exploits. Network congestion. During periods of high network congestion, transaction confirmation times can be unpredictable, making it even harder to control which transaction gets confirmed first. Ethics attempting to defraud a service is unethical and can have legal consequences. 3. Detailed steps and code example, Python with blockchain.info API, deprecated, but serves as an example. Important notes blockchain.info API is largely deprecated. The code is provided as a conceptual illustration. You'll likely need to use alternative blockchain explorers, example Blockchair, BlockCipher, and adapt the code accordingly. This example is simplified and does not include error handling, input validation, or private key management best practices. Never store private keys directly in code. This code assumes you have some familiarity with Python and Bitcoin transaction basics. Step 1. Install necessary libraries, if applicable. Step 2. Define helper functions, illustrative, using a hypothetical blockchain.info replacement. Step 3. Main script, illustrative. Explanation 1. Get_balance, get_unspent_outputs *. These functions, implemented using a hypothetical blockchain.info replacement, retrieve your Bitcoin balance and the unspent transaction outputs, UTXOs, associated with your address. UTXOs are like individual coins you own. 2. Create _transaction *. This function attempts to create a raw Bitcoin transaction. The provided implementation is a simplified placeholder. You must use a proper Bitcoin library for real transaction creation. It takes a list of inputs, UTXOs to spend, a dictionary of outputs, addresses and amounts to send to, and your private key, for signing. 3. Broadcast _transaction *. This function broadcasts the raw transaction to the Bitcoin network, making it available to miners for inclusion in a block. It also uses a hypothetical endpoint of a blockchain explorer. 4. Main ***. Retrieves UTXOs for your address. Simulates a free Bitcoin roll, using deposit funds to roll and hope for the highest payouts possible. Creates two transactions, TX1 and TX2. TX1 sends Bitcoin to your free Bitcoin deposit address. This simulates a real deposit. TX2 attempts to double spend the same inputs as TX1, sending the Bitcoin back to yourself. It should have a higher transaction fee than TX1. Broadcasts both transactions. Sleeps for a short period. The theoretical exploit relies on TX2 being confirmed before TX1. If TX2 confirms first, it invalidates TX1, because the inputs have already been spent. You would then have the winnings from free Bitcoin and your original Bitcoin back. 4. Important considerations and caveats. Private key security. Never store your private key directly in code. This is extremely dangerous. Use environment variables, a dedicated key management system, or hardware wallets. Bitcoin libraries. You must use a proper Bitcoin library, example Pcoin, BitcoinLib, to create and sign transactions correctly. The provided create _transaction is a placeholder. Fee management. Dynamically calculate appropriate transaction fees based on current network conditions. Overpaying fees can make the exploit unprofitable. The get_fee_ recommendation is a step in the right direction. Transaction broadcasting. Broadcast transactions through multiple reliable nodes to increase the chances of them being seen by miners. Free Bitcoin countermeasures. Free Bitcoin has likely implemented various measures to detect and prevent this type of manipulation. Don't expect this to work. Transaction replacement. RBF Bitcoin supports replace by fee, RBF, which allows you to replace an unconfirmed transaction with a new one that has a higher fee. Miners are increasingly adopting RBF, which makes it harder to control which transaction is confirmed first. Race condition *. This exploit relies on a race condition between TX1 and TX2. Controlling which transaction gets confirmed first is very difficult, especially with modern mining pools and RBF. Legality and ethics *. Attempting to defraud services is illegal and unethical. Why this is unlikely to work in practice. Miners prioritize first seen. Miners generally prioritize confirming the first transaction they see, spending a particular input to maintain the integrity of the blockchain and prevent double spending. Free Bitcoin's vigilance. Free Bitcoin is aware of these types of exploits and likely has systems in place to detect and prevent them. Confirmation delays. Free Bitcoin might delay payouts until transactions are confirmed, negating the exploit's window of opportunity. Network congestion. During periods of high network congestion, transaction confirmation times are unpredictable, making it almost impossible to reliably control the order in which transactions are confirmed. Ethical considerations. Attempting to exploit vulnerabilities in services like Free Bitcoin is unethical and could have legal consequences. 6. Conclusion. While this tutorial outlines a theoretical vulnerability and provides a code example, it's important to understand that successfully exploiting Free Bitcoin using this method is highly unlikely. Modern Bitcoin mining practices, security measures implemented by Free Bitcoin, and ethical considerations make this a risky and potentially fruitless endeavor. This tutorial serves primarily as an educational exploration of blockchain transaction mechanics and should not be used for malicious purposes. Disclaimer: repeated this tutorial is for educational purposes only. I am not responsible for how you use the information provided here. Attempting to manipulate or cheat Free Bitcoin, or any other faucet/service, is against their terms of service and may lead to account suspension or permanent ban. Consider this a research project and use the information responsibly. Remember that creating malicious applications can create significant legal and financial ramifications.